Welcome to e-learning. This time it's about calorimetry, basics and applied. The aims of this exercise are that you learn how to use the calorimetric formula Q equals M times C times delta theta. And here you can see what the different symbols stands for and which unit they have. Calculate the amount of energy used to heat the water in a hot water storage tank. Note we neglect the energy used for heating the tank itself and the heat loss from the tank and the tubes. Calculate how many joules there are in 1 kilowatt hour. And calculate the price for heating the water in the hot water storage tank when you know the price for a kilowatt hour. Let's take a look at the exercise. We have to calculate the amount of energy used for heating 300 liters of water. We know that the inlet temperature is 10 degrees and the final temperature in the tank is 55 degrees Celsius. I have written up the equation to use, and as you can see I have put on indexes for the water. That's the chemical formula. First I want to figure out what is the mass of water. And as you may remember, I have 300 liters of water, and that gives 0.3 cubic meter of water. And when I times it with the density of water and use my calculator, I get 300 kilograms of water. Next thing I have to figure out is what is the specific heat capacity for water, and it is a material constant, and we look it up in a table. The table here shows specific heat capacities of selected materials, and what we're looking for is this one, the water down here. And if you look at the unit, it is joules per kilogram times Kelvin. It means that it takes 4,181 joules to heat up 1 kilogram of water 1 degree. I have written up the value for the specific heat capacity for water. And as you can see, I have changed it to kilojoules. Next thing is to find the difference in temperature. And remember that the inlet temperature was 10 and the final temperature was 55 degrees Celsius. So I find the difference in temperature in degrees Celsius, and that is 45 degrees Celsius. So I convert to Kelvin. And I know that a difference in temperature of 1 degree Celsius is equal to a difference of 1 degree Kelvin. And that means that my 45 degrees Celsius, the difference in temperature, becomes 45 Kelvin. I have filled in the formula for finding the energy for heating the water. Here's the mass for water, here's the specific heat capacity for water, and here's the difference in temperature. I use my calculator and I get 56.44 megajoules. Next step is to calculate the price for heating the 300 liter when the cost of 1 kilowatt hour is 0.75 Danish kroner per kilowatt hour. Take a look at how we convert kilowatt hours to joules. 1 kilowatt hour holds, first of all, 1000 joules per second, because this is how much 1 kilowatt is. And when we have an hour, we have 3600 seconds. Timing those two together gives us 3.6 megajoules each time we have a kilowatt hour. Finding the price, I have to take the value for heating the water. I divide it with how many joules I have each time I have a kilowatt hour, and then I times it with the price, and the result is going to be 11.76 Danish kroner. Last thing is to find the price for heating 1 cubic meter of water. Here I have written up what the price is for 1 liter, and there's 1000 liters each time you have a cubic meter. So when you times the things together, you will get that the price for heating up a cubic meter is 39.19 Danish kroner.